Hello, so today I'm going to be going over the 2011 Calculus BC free response question number 3, which is a non-calculated problem. So let's go ahead and jump right in with part A, which asks us to write but do not evaluate an expression involving an integral that gives the perimeter r in terms of k. Okay, so part A wants us to find the perimeter, and we already know that there aren't any formulas for finding perimeter of the shapes, and that's because we don't really need one, because if we think back to our geometry days, finding the perimeter of an area or a shape just really requires adding up the lengths of all the sides. So for part A, we're going to start off with the simple sides to find the lengths of. So the first one is from the y value 0 to the y value 1, so just subtracting we get a length of 1. The next one is from 0 all the way to k, and that's fine. Just because there's no actual value of k, we don't really know the value, we can still just put it down as the length of k. And the same thing with this one, so we have from the y value 0 to the y value e to the 2k, so that's still just going to be e to the 2k. But our final side length is actually a little bit of a curve. So we can't just subtract between these 2 points because it curves, it's not in a straight line. But we do know the arc length formula. So to remind everyone of the arc length formula, we have the square root of 1 plus f prime of x squared. And then we integrate that between the 2 points that we want, so from A to B. So let's apply that to this problem. So our f of x is e to the 2x. Okay, so f prime of x is 2e to the 2x, and that's just, we use our chain rule, so we have e to the 2x, bring down our 2. Perfect. So here's how we add that. So the 2 x values that we want are 0 and k. So from 0 to k, now we have the square root of 1 plus 2e to the 2x squared. And then you're going to write dx. Perfect. So this right here is going to be our actual perimeter of area R. And you don't actually have to solve this or anything. You don't have to integrate and plug in your k and 0 because it asks us to just write it out. You don't have to evaluate it. Okay, so here's a look at the scoring guidelines for this problem. So this problem is worth 3 points. 1 point for actually writing the derivative of the problem, 1 point for the integral, and 1 point for the answer, so everything together. It's really important to remember that you have 15 minutes for these problems, and if it's kind of a problem you're unsure about, you really just want to try and maximize the amount of points you can get. So how you can do that is by showing all of your work, because sometimes it's kind of arbitrary what they give points for, because even if you know the derivative of e to the 2x, they still want to actually see it on there. So if you were to write 1 plus f prime of x squared, that's not enough for them. They actually want to see you derive f of x. And so just write that out. Make sure you actually put everything together and you write out the integral. So those are the points that they really want to see. Part B says the region R is rotated around the x-axis to form a solid. Find the volume V of the solid in terms of K. Okay, so this is a volume problem. We've done this lots of times in AB, and so it's not a cross-sectional volume. This is where we use pi and then we square our f of x. So let's write out our integral. So this is our volume V is equal to pi. So we're going to multiply this by pi, and then we evaluate that from 0 to k, because those are our 2 x values. That's kind of the bounds of our distance, our area R. Now we have our f of x, e to the 2x. We square that, and then we have our dx. Now we have our v equals pi 0 to k. I just simplified this. I brought our 2 in, so it's e to the 4x dx. And so now, when we integrate this, I left the pi outside. And so this is our e to the 4x over 4. So you could substitute this. I just thought it was a little bit more intuitive to think about how e to the 4x is going to stay constant when you derive and integrate, but you have to divide by 4 because when you derive something, you multiply down. So when you integrate, you divide by it. And so this is just saying that it's evaluated at k and it's evaluated at 0. So I went ahead and did that. I have our pi times our e to the 4k divided by 4 minus 1/4, because when you plug 0 into here, this just becomes 1. And so then I distributed our pi. And so now we have pi times e to the 4k all over 4 minus pi over 4. Here is the scoring guidelines for part B so that we can compare our work to theirs and also see how they've given up points. So this is worth 4 points, the most out of any of the parts here. So they've done the same thing. So they've kind of written it out. They simplified it as well. They split it up, and then they have their final solution. So they gave points for the integrand, the limits, the antiderivative, and the answer. So they actually wanted to see that you knew that you had to integrate from 0 to k as our bounds right here. And they actually wanted to see the antiderivative, so they want to see the work for that. So even if you can kind of do this in your head and you can say, oh yes, I know that you divide by 4 and your pi's out front, they actually want to see you write that out, and they want to see your k and your 0, and they want to have you have that answer out here. And then 1 point for the answer, of course, just to make sure that you actually could do all the work correctly. So that's how they gave points for that. So part C is the third and final part to this question 3, and it asks the volume V found in part B changes as k changes. If dk over dt, the derivative of k, based on how t changes, is equal to 1/3, determine dv dt, how the volume changes as time changes, when k is equal to 1/2. So it's asking for the rate of change of the volume. So initially this seems like a related rates problem, and it kind of is, but you don't actually have to go through all the work of figuring out like what your formula is, because it tells you that it wants the one that you've solved for in part B already. So if we rewrite that out, we have volume V is equal to pi times e to the 4k over 4 minus pi over 4. So that's what we already wrote out. So how we solve for this is it's asking for the derivative of volume. So that means that we have to derive the whole thing. So we have dv over dt is equal to pi times e to the 4k times dk dt. And so how we got that is when we derive this, so we think about this kind of our coefficient right here. We have to derive this and we bring down a 4 which cancels with this right here. So we just have pi times e to the 4k, and then we also have to take our derivative of k, which is dk over dt. And this right here is a constant, so that's just eliminated. Now that we have this, it tells us what we actually have to evaluate it at. So it says when dk dt is equal to 1/3, and also when k is equal to 1/2. So I went ahead, plugged those in, which is pi times e to the 4 times 1/2 times 1/3, which just gives you dv dt is equal to pi times e squared over 3, because 4 times 1/2 is just 2, and I had everything. I brought the 3 to the denominator, and so that's going to be your answer. Here are the scoring guidelines for this question, which is kind of interesting because they actually showed less work than I did. So it gives out 2 points, the actual least amount of points for any part on this question. 1 point is for applying the chain rule, which is over here with the 4k and also the dk dt, and just 1 point for the answer. So sometimes it's kind of arbitrary, like the points that they give out, but it's better to err on the side of caution and show more work rather than less, because you want to make sure that you're getting points for what you know how to do.